So today I'm going to talk to you about something called dimensional analysis. And I'm going to be completely honest, and I'm going to give you probably more information than you need to know about this. This is something that I learned as a sophomore, a 10th grader in high school in an honors chemistry class. And I struggled with it all year. And it didn't really make sense to me until I was an adult. So I'm going to try my best to teach it to you in a way that I think a middle schooler can understand. Once I learned it, I actually really like this method. For the type of problem that we're doing today, it might seem like a little bit more work than it's worth, but it's always the same for every problem, and I'll explain that to you in a second. When we do some things later in the year that we have to convert rates, this is actually a little bit more helpful than the other way. It's because the problems today are very basic and introductory that it's going to seem like a lot of work, but there is use for this. So try to wrap your brain around it. I have some things posted in Google Classroom that hopefully will help, and we will get through this. Okay, so when I learned to do converting measurement systems as a middle schooler, we just learned to multiply and divide. You find the factor, the conversion, and you multiply or divide. I could never remember when to do which. I was terrible at this topic because I could never remember it. So with this method, with dimensional analysis, it doesn't matter. It sets it up for you. Every problem gets done the same way. That having to remember which to do when is completely out. Okay, so I do have the steps posted in Google Classroom. I'm going to show you what that looks like and do some flipping back and forth between my screens. The conversion chart will also be helpful to you. Of course, we have it at our fingertips with smart devices and the internet. The one that you might like is on page 320 in your textbook. If you happen to have that in front of you, you can just leave that open. It's also on the steps that I have listed. A lot of times they're in the back or the front of notebooks, like marble composition books will have a chart if you're ever in a situation where you aren't allowed to use a device to access it. Okay, so let's go to what this looks like. So here's the conversion chart. I've copied it onto the paper. It's the same one that you'll find in your textbook, maybe in a slightly different order, but that's the basics of it. So dimensional analysis. You start off by writing the example, and this is a situation that you would encounter. So 15 quarts is how many gallons? You write the original. Ta-da! You make a set of parentheses with a fraction bar. Ta-da! The book does not teach it with parentheses, but when we get to it later in the year, students have told me that the parentheses are super helpful because you do it for each change that happens. That'll make more sense coming, but getting good habits now. Okay? You're going to write the original units on the bottom of that fraction. So our original units were quarts. This is on the quarts. The quarts are on the bottom here. And then the new units go on the top in the numerator. We're switching to gallons, so I put gallons on the top. Notice there's no numbers here yet. I'm just putting in the labels. Then we're going to look at the chart. We're trying to find the conversion, and we fill in the numbers. So let's go up and see if we can find quarts and gallons right here. So 1 gallon is 4 quarts, and it's important that you read the whole thing because sometimes things are flipped upside down. So 1 gallon is 4 quarts. I'm going to fill in the numbers based on the labels. 1 gallon was here, so the 1 goes with that, is 4 quarts. Quarts is on the bottom, so the 4 goes with that. Then we get to cross cancel the units, just like we were doing with the fractions with multiplication. This is really over 1, right? This is really in the numerator, the 15 quarts. So I've got a quart on the top and a quart on the bottom, and they are gone. The only label left is gallons, which is perfect because I'm trying to find my gallons. Then it's multiplying fractions, which I think is why they put it in this section of the book. So 15 times 1 is 15. What would be a 1 underneath times 4 is 4. My answer is 15 gallons for every 4, I don't know, there's no label there, but I can divide. So if I take 15 fourths and I change it to a decimal, that's 3.75 gallons. So 15 quarts is 3.75 gallons. Now, that's kind of hard to follow with me just talking through it. Let's flip back to my notebook, and I want to work through one with you. All right, let's look at something like 17 and 22/100 inches is equal to how many centimeters? Inches and centimeters. It's not even the same measurement system, but we can do this. So my steps: write my original, put a set of parentheses with a fraction bar in the middle. Put the original units on the bottom. I started with inches, so I'm putting inches on the bottom. Put the new units on the top. I'm switching to centimeters, so centimeters goes on the top. No numbers in here yet. All right. Now I happen to have the chart in front of me on page 320. Ta-da! So we're switching between inches and centimeters. Let's see right here. 1 inch is 2.54 centimeters. So let's see. 1 inch, right? This is where the inches are, so this is where the 1 goes, is 2.54 centimeters. Now I got a math problem. I see inches on the top and inches on the bottom. Bye-bye. And I'm left with centimeters, which is good because that's what I want. And then it's multiplying fractions. These parentheses really mean multiply. You can put the times sign in there if you want. So 17.22 times 2.54 is 43.7388. And 1 times 1 is 1. I probably don't need to write that. The only label that has not been crossed off is centimeters. So there's my answer. 17.22 inches, a little bit over, almost a ruler and a half, would be about 44 centimeters. Okay, let's do one more. Let's say I have 5 kilometers, kilometers some would say, and we want to know how many miles that is. Usually this is MI. Okay, very common conversion for runners because we usually measure races as 5K, 5 kilometer. But in the United States, we talk about, oh, I went for a 3-mile run. So it's handy to be able to convert them. Same steps. Write what I'm given. Make a set of parentheses with a fraction bar. Put the given units on the bottom. The new units on the top. Exactly the same as every problem I've done to this point. Then I go find my handy dandy chart. This is going to be in length or distance. So let's see, 1 mile is 1.61 kilometers. Kind of flipped from what we had before. But the 1 goes with the mile. Here's the mile, that's the 1. And the kilometers was 1.61. I get to cross stuff off. If you like office products, if you like colored pens and pencils, great time to bust them out and use them on this. Kilometers and kilometers, bye-bye. Nothing else gets canceled because nothing else is duplicated. The miles is all by itself. None of these numbers have anything in common. Then it's like multiplying fractions. 5 times 1 is 5. 1 times 1.61 is 1.61. I usually don't walk around talking about my runs as, yeah, I did 5 over 1.61 miles today. What? Nobody knows what you're talking about. So don't think of this as a fraction bar. Think of that as a division sign, because it is. So you bust out your calculator and you type in 5, divide 1.61 equals, and you're going to get something around 3.11. The only label left was miles, so it's about 3.1 miles. The labels are super duper, duper duper important for these.